Thank you. And you can hear me fine, everybody? Yes? Okay, welcome back from lunch. I hope you're not too sleepy. I'll try to make it dramatic. I certainly had some drama in the break here. Turns out my laptop did not connect to the display, so that was my break. Now it's working, but I'm still in a mild state of panic. Yeah, my name is Peter. I'm from Copenhagen. I've been a front-end developer for 15 years now. Time flies. I'm very much into tooling. I want to enable people to do complex stuff in a simple way. And this talk is about techniques, how to load web fonts fast, and also tooling that I built to help you do that. So first of all, according to the HTTP archive, which scrapes like millions of pages based on Alexa rank, so like the most popular pages on the internet, 70% of those pages are using web fonts. And that is a performance problem, because if you don't do something extra to make your web fonts perform, then it will actually detract from your performance. And that has to do with the way fonts are loaded. But I'm gonna preempt myself and actually start out with a demo, and then we can look at the difference between what a default web font performance profile could be and what an optimized one could be. So I'm going to start out with showing you the tool, and then I'll walk you through the techniques applied, which you could also apply manually, and then I'll explain things as we go. So first of all, I have a blog, very rarely updated, like 2 years ago. So this is a standard Jekyll site. It's hosted on Netlify, so I get static file hosting, which is fast. I have a CDN, which delivers things fast. I run a static build system on this, so everything's optimized. There's bundling, there's minification, there's compression, all of those things. The performance profile is actually not that good. So I can show you, first of all, I'm going to run the demo here. If network permitting, I'm going to run my tool here. I'm going to install the tool called Subfont, which is an open source tool I built. If the network doesn't work, we just skip ahead because I have a fallback. Looks like it's working. Thank you for not running Dropbox right now. Nice of you. Okay, I installed Subfont, so I'm gonna open my package.json, and I'm gonna augment my build system. My build system is currently bundle exec Jekyll build, so it's a Jekyll page. And after I've done that, I'm gonna say subfont build/index.html, which is where the build artifacts from Jekyll will be. I'm gonna say -i, which means that it'll clobber the files, which I'm fine with because it's a build artifact. And then I'm gonna say inline CSS, save. And then I'm gonna do npm run build. So what will happen now is the Jekyll build will run. I'll have a build artifact and index.html. Subfont, the tool, will go in and statically analyze the page, figure out that I have Google fonts, and then it'll do magic, which I will show you in a moment, network permitting, because now it's actually going on the network to fetch fonts from Google Fonts. And then my post optimization tool is ran, just like normally. And I cheated. I already prepared a web page test org run on my master before the optimization, and one after, and it looks like this. So I don't know if you can see this. The upper timeline is my blog, as I just showed it to you on the different tab. It takes 4.5 to 5 seconds before I get the first paint, and then it takes slightly, somewhere in between 6.5 seconds and 7 seconds to get the fonts. That's a long time. This is done on a Moto 4G and a slow 3G connection that is deemed to be the current global average. So if you have pages that you're interested in also serving in South America, Africa, Asia, then you want to perform on this profile. The bottom timeline is the after I ran this tool. And you can see that I have a first paint at 4 seconds instead of 7 seconds because I already have the fonts. That's a massive difference. And obviously the difference will be less pronounced if you have a fast network and a fast CPU, but the difference will still be perceivable. So let's look into why is there this massive difference. And the upper line is running Google Fonts as suggested by Google Fonts. It's included with a link tag. It's including the style sheet from Google Fonts, which will then eventually point at the font files which are needed. So let's look at the timeline. Is this big enough that you can see it? I think I can up it one more. There we go. All right, so this is my page. You can see the initial request has a slow DNS, it has a slow connection time, it has an SSL handshake, then it has a round trip for waiting for the data, and then the index HTML drops in. That's at around 2.2 seconds. Then a bunch of new connections are triggered, my CSS, some images, and the Google Fonts CSS. And then you see, oh, I need another DNS, I need another connection, I need another SSL round trip, and then I need another round trip for the data. And then the green line indicates that now the browser is ready to render. Now it has loaded this external blocking Google style sheet, and it says, oh, there are some fonts, and I need to fetch them. And then it does another DNS lookup, and another connection, and another SSL handshakes, and then it downloads the fonts. This is very slow, and this is like what Google serves you as the default. It doesn't even serve the fonts from the same domain as the CSS. So you don't already have a warmed up connection which you can request the fonts on. If you use Google Fonts out of the box, this is what you'll get. And we can do better. So this is the after timeline. I'm going to switch back and forth so you can just see later. So what happens here is that my index file comes in approximately the same time, that there's no difference. And then immediately I download the 4 fonts, in parallel with requesting my style sheet and all those things. And then you can see later, after the paint, after the 3.2-ish seconds, the green line, where the browser has already rendered with fonts, it does some more things. It downloads the Google Fonts CSS, and then it loads another file. That's a bug I can't explain right now. I'll fix that eventually. So you can kind of perceive the difference that here you have a very horizontal waterfall chart, and here it becomes more vertical. So it does more things at the same time, leverages HTTP2 and downloads things in parallel. So I'll show you which techniques I used to achieve this, but let's first do a small video comparison. So just to have a feeling for what the perceived difference is. That's what the user experience is, right? Okay, let's dive into what actually happened here. This should probably be smaller, and this should be prettier. Okay. So this is where things get interesting. My tool looked at the original link include from Google Fonts for the style sheet, and then it analyzed the page, pulled down the pages to local, which means that now I can download the font, or it pulled down the fonts to my local server, which means that now I can reuse my already warm HTTP2 connection from my host. And I preload the fonts, which have a known file name. The trick is, with Google Fonts and with any web font provider out there, like Typekit or similar, none of them provide stable URLs for the font files. So you cannot even put a preload header and say, I want to preload this WAF file, because eventually it might change the URL. So you cannot guarantee that it actually works. The worst case is, you'll spend the download time on downloading the font file, and then you download a different font file, which is essentially the same thing. So by pulling it down on your own server, you can leverage the preload by having a guaranteed file name, and you can use your already warmed up, already connected HTTP2 connection. If you remember one thing, then it's this one. This is like 80 to 90% of the speed up you just saw. All the rest is just geekery, like preload and get your fonts local. So there's one more thing I'm doing, which is cheap, which you can do yourself when you have the fonts local. You can add a font display. Font display has a few options on how to deal with the limbo in between the page being rendered and the font being downloaded. And I recommend having font display swap, which will immediately draw the fallback font as soon as your page renders. And then whenever the web font comes in, it switches them. Because this means that the time to meaningful paint, the time where the user can actually read the page and see if it's useful, is the same as the time to first paint. So it allows your users to immediately see, do I even want to be here? Do I want to scroll or engage with this page? And then eventually the nice experience will come in when the web font drops in. So in order to serve it from local, I'm using the same technique as Google does. Prefer local. Otherwise, use this URL for WAF2 and this URL for WAF. You don't need to make any more gymnastics these days. The browsers are good enough that basically all the browsers you want to support already support WAF. And I'm preloading only the WAF2 files because preload support is a subset of WAF2 support. So it's safe to say preload the WAF2 files, because if the browser doesn't understand it, it's a guarantee that it probably doesn't understand WAF2 either. And then I'm doing something tricky. So there's a little script down here. Preload is supported by around 60% of all browsers. But there exists a CSS font loading API, which you can access through JavaScript. And through this, you can actually trigger a load of the font, even for browsers that don't have preload support yet. This is what Font Face Observer does, if you've ever heard of that, which lets you do a promise-based thing where you say, I want to load this font, and when you're done, I can switch classes so I can do a loading spinner or control the experience in the in-between, in the limbo between not having the font and having rendered the page. This is the very short version. What it's doing is it's iterating through the fonts on the page, and then I'm saying, if it has this specific name, underscore subset, which I'll come back to, all of these above have underscore subset in the name. So if it has underscore subset in the name, please try and load it. And there's a try catch around it because this API isn't supported by all browsers. So I'll just do an empty error handling. I don't care about the result, I just want to trigger that download immediately if it's available. Again, if you remember anything, these are the preload things you can do to get 90% of the speed up I just got. So now let's talk about the hairy stuff. I'm not okay with 90%. I want to enable people to get perfect results with very little work. So I thought this subsetting thing, selecting a subset of glyphs that are used on my page and excluding the ones that are not using on my page, that seems like a doable thing, right? There are tools to do it. If you know what glyphs you have, you can apply a tool on your font, and then you can get a reduced font that only has the glyphs you need. Easy, right? So after we did this, we coined a concept called hybris-driven development, and that's what this is. You think it's easy, and then it just keeps going. So let's dive into what's actually happening. So you see that after I've figured out how to know what glyphs I have on my page, that's hard. I do this thing where I have a new name for the font. The original name was Noto Serif. Now the name is Noto Serif underscore subset. So I'm actually including the subset here. And I've modified my CSS so it points at the subset. This is not recommended practice. In fact, web font experts will specifically tell you do not do aggressive subsetting. It is an anti-pattern. And it just so happens that, so this is an example of a subset where only the English character sets are downloaded, but it has this effect if you do it wrong. You might recognize this as Germans. I have a U umlaut in my last name. I've had many different renderings of U umlaut, both this one and also different characters, especially airlines. But what happened here was there was a subset and somebody forgot to include U umlaut in the font. So that one glyph is rendered with a fallback font. And in this case, the fallback font doesn't really look anything like the web font. If you only serve a subset, then you might run into this, especially if dynamic stuff is happening on your page, a comment by somebody is loaded, they're Chinese, and they write in Chinese, then it will definitely not be in the web font that you anticipated. So I came up with a new technique to load a subset and use a subset, but still have a proper fallback. So at the time where a new glyph loads or is needed, it will actually load the original font. So that is on demand. And I have not seen this technique before, so I'm gonna try and show you if I can find where this is used. So I'm pre-connecting to two more URLs. One is fonts.googleapis.com, one is fonts.gstatic.com. Those are the places where the CSS and the fonts are hosted on Google Fonts. So I'm already warming up the connection just in case I need to load the fallbacks. Then all the way at the bottom, I have this ugly block, which is a script and a no script. And that's essentially loading the CSS, the original CSS from Google Fonts that I had, but in an asynchronous way. When you script append a link tag like this, it'll load asynchronously. So I've just removed that slow connection time and round trip to Google Fonts from my critical rendering path. But I still get the stuff, but it's just not in my critical path anymore. So I'm warming up these connections, and in order to both use the subset and enable me to fall back to the original web font, I will need to look into build/something.css, main.css. It's probably in Note-to-Serif. There we go. So I've rewritten all the usages. So this was my original usage. I said I want to use Note-to-Serif and fall back to serif, but now I've prepended this subset. So the effect of this is that if a glyph is missing in a web font, these declarations will be tried in order. So it'll start with my subset, figure out this glyph is missing, then it'll load the next one. At least that's the spec. And Chrome and Opera does it correct. Firefox has a bug, which I'm tracking right now. Edge also has a bug where they load these things up front, which means that you pay more bytes, but it actually doesn't affect your time to first meaningful paint, because the subset is already preempting and you can already render before. So even though some browsers are loading a few more bytes, there's still no downsides if your goal is to get a first meaningful paint faster. So I skipped over the hard part, which was figuring out which glyphs I'm using. It sounds easy, and that's what we said. I happen to be a former colleague of one of the web's foremost web font experts, Bram Stein. Years ago, we worked at the same company, and so we were having a reunion beer like 2 years ago, and I was sitting there with another different colleague, and we were like, Bram, this subsetting stuff, how hard can that be? Like, you could just statically analyze the fonts or the text on the page, and then you know what glyphs you use, right? And he goes, no. You cannot do that. There's all sorts of things. And we're drunk and we're not listening to him. We're like, yeah, we can do this. So the reason why we were that cocky is that we spend a lot of time building static analysis tools, which look at a page as a whole, as one single data model. It has access to the DOM, to the CSS, to JavaScript, everything at the same time, which means that we have the basis to do a static analysis that would know which CSS applies to which text. So that's a tool set called Asset Graph, and it's using JS DOM internally to model HTML. So when we started doing this hybris-driven development, we thought we'll just get computed style, and then we have the font properties that we're interested in, and then we can figure out how they group to the font files, and then everything is good. Hand it off to a subsetting tool, and then we have a result. JS DOM does not have get computed style for inherited properties. So we implemented it, which turns out to teach me a lot about how CSS font resolution is actually working. So just to do a short walkthrough, you see the declaration, you see which selector applies to which DOM nodes, then the declaration is followed, you figure out there's a specific font, you look up the font face declaration, you see which weights it has, and if it's italic and not, then that classifies it to which fonts you need to download So now you have the weights and the approximate font, and then if you don't have all the fonts for all the weights that you specified, it'll snap to the ones available, and then you need to take care of things like you can set a CSS property called font weight bolder, which means that after all this snapping has happened, it's going to say, oh, you want it, I'm in a context of already bold, but I want bolder. I'm going to do one higher of whatever is available. So all of these things are very dynamic and very hard to track. Then you have CSS generated content, you have visible attributes like placeholder attributes. Then you have potentially different states, hover states, active states in CSS. You have media queries. Suddenly this problem is not just I have a text node and I'm getting the computed style. It's multi-dimensional, multiple states at the same time, which all might affect which glyphs end up in which bucket for which font file. We ended up actually implementing all of this. And I have not seen an implementation of this before, so I think this is genuinely a new contribution. There exists a different tool called Glyphhanger, which does get computed style for text nodes, also for attributes, but doesn't do the state thing. So if you're interested in trying to look into that, Glyphhanger is easier code to read. Look at that, and if you're daunting, then come speak to me and I'll walk you through our code and how we did this. So this tool only works for static files, for static pages. So this means that if you have a static page like Jekyll, or if you use Hugo, or I don't know, there's a lot of different static page generators these days. This is a tool for you. You can keep doing the default recommended style of including Google fonts like this. It also works with local fonts. There is a Python dependency if you want to do local subsetting. It'll help you install that when you hit that. But if you have a dynamic page, you might be out of luck. Dynamic pages take several forms. Some maybe have a static loading screen or a static header. Then you could still run this and you could get immediate rendering of your static header. But the dynamic parts, it doesn't really cover. So if you want to do font subsetting, again, I cannot repeat this enough. Don't do font subsetting for that. Just don't. Like, it will not be enough to know what's in your translation system or what's on your pages, because there are weird states you can get into and you cannot predict them when you do dynamic JavaScript. That said, preload. Preload, preload, preload. Remember that. Go home and do it. It's like a half-an-hour change. You can download the web fonts from Google. The license allows you to. They're available on GitHub. I think they're even available as NPM installs. You can point a preload link. You can use an HTTP header if you have access to set your HTTP headers. This increases your performance immensely. So go and do that. So I encourage you to try this. I want to help you. Like, if you have time in a break, I'll help you set this up if you have a static page and see it break in all the funny ways that it can, and then I'll have bug reports that I can fix. But I want to close off with this is just one instance of a tool as I think it should be built. I think there are not enough tools that allow you to work in a non-complex way and then abstract the complexity away from you. Most of the tools that exist expose you to tons of complexity with configuration, because you have to tell it everything. You have to tell it every entry point, everything to do. You have to tell it how to do it, and you don't tell it what to do. So I want to build tools and I want others to build tools that let you achieve the goal and then just look at your code and does the right thing. And I think this is one example of such tool. I might do a lightning talk later where there might be another one. I want these tools to give people abilities without having to know all the crazy stuff that is behind it. That subsetting stuff is so hard, I don't expect anybody to know it. Like, I don't even expect web font experts to do it because it is so error prone. So I'm really hoping that I can contribute, that people can do this and win something from it. But Again, subsetting, that's just the geekery. I'm loading slightly less fonts. It's not where the gains come from. Do preloading. So I'm really also hoping that there might be designers in the room, or people who specialize in HTML and CSS only, and don't necessarily geek out on web performance like I do. And I hope that they can use this and that they can build faster experiences. So I think that's all the words I had. I think this room is not so good for questions, so I think we'll forgo them. I'll be in front of the stage, and you can come and ask me questions if you're interested. And I'll leave you with those words. Take a look at Subfont. You can install it from NPM if you want to, and give it a go. And tweet at me if it doesn't work. I'll fix it for you. Thank you.